students, today in continuation with the current electricity, last class we discussed cells in series. Today we will discuss about cells in parallel. When we connect them in parallel, how the combination works. So I am talking about cells in parallel, and here I have taken two cells like this, and one is this and another is this, and they are in parallel. This is E1, this is E2 with the current I1 from E1 with the current I2 from E2, and this is the total current, and its internal is say R2 and its internal is say what? R1. So we are going to calculate its combination across two ends, and you know that how we are going to calculate it. And the equivalent, we say that say E equivalent is it's the EMF and I is the current, and what is the equivalent resistance? Say R equivalent is the resistance. So this is A point, this is C point, this is A point, this is. So we are going to prove how this works and what will be the equivalent EMF. And the conclusion is that the equivalent EMF which comes here, I am going to write the formula, that is E1 R2 plus E2 R1. Remember, by what? R1 plus R2. This will be the equivalent EMF that will be calculated. And R equivalent already you know, because they are in what? Parallel. So I can directly write R1 R2 upon what? R1 plus R2. So this will be the conclusion for equivalent EMF and equivalent resistance in what? In parallel. Now we find out it. Do you know in parallel what is same? V is same. Potential difference is same in both the cells. So all of you know that V is what? E minus IR. So I can write V equal to E1 I1 R1, and V will be what? E2 minus what? I2 R2. These are the voltage in both the cells. This is say for first cell and this is for cell. And as we know that I is what? I1 plus I2. So in place of I1, can I write V minus E1 or V minus E1 by what? R1. Okay, and can I write the same thing here, plus V minus E1 by R2, or we can say minus V plus E minus V plus E. If you see how you got it, I1 is what? E1 minus V by what? R1, and I2 is what? E2 minus V by what? R2. So this we can write. Okay. So we have written this. So now we'll proceed further. So I is E1 minus V by R1 plus what? E2 minus V by what? R2. And then we can write E1 by R1 plus E2 by what? R2 minus V. And in bracket we can write R1 plus R2 like this. And then certainly we have the relation here E1 E2 R1 upon what? R1 R2, and here we have what? R1 plus R2 upon R1 R2. Got it? Now what we will do, that we will take V on the other side, and can we write this like E1 R2 plus E2 R1 upon R1 R2 minus I. We have taken on the other side, and then you take it down, this one, this part. So if you take it down, do you know what you are going to get? E1 R2 plus E2 R1, and directly I am going to write it, I will get R1 plus R2 here, and minus I R1 R2 upon R1 plus R2. Got it? You take it in this side. Now you know that as V is equal to what? E equivalent minus what? I R equivalent. So we'll compare this third and fourth equation. So comparing, you can calculate what? What is the equivalent EMF? E equivalent comes what? Do you know? E1 R2 plus E2 R1 upon E1 plus E2, and what is R equivalent is what R1 R2 upon R1 plus R2. So this is the conclusion of this equivalent EMF and equivalent resistance. Okay, got it or not? So this is the way we have described it. Again, I am repeating, we have two cells in parallel and we know that we are going to get it. Current is what? Different in parallel. Potential difference is same. We know that V is E minus IR. So both potential is same. We can get I1, I2. I is I1 plus I2. Then I can write in this form. And then what happens? You know that I can separate it like this and then calculate it. Then V equal to E minus IR. We take on this side and then it will go down. And then both will be compared. And this will be the equivalent EMF and equivalent resistance. So this is how the cells in series and parallel behaves. So final thing is that if there are two cells in series, I am going to write it, okay, and they have E1, E2. So net EMF is what? E1 plus E2, okay, and they have internal say R1 and R2. Net resistance is what? R1 plus R2. Then we know that if there are two cells but they have opposite terminals plus minus, and now they have like terminals here, minus minus connected, and they have internal resistance R1 R2. Do you know what will be the EMF? EMF will be E1 minus E2. R will remain same. Why? Because here I have taken E1 greater than E2. If I take E2 greater than E1, E2 minus E1. And the third thing which we understand is that if there are two parallel cells, are you getting it? And say it is E1 and it is E2, its internal is what? R1, its internal is what? R2. Okay, so we got it that what will happen? E will be what? E1 R2 plus E2 R1 upon R1 plus R2, and what will be R? R will be R1 R2 upon R1 plus R2. These are the two things which we have seen in this case. Cells, one is this and the another is this and another. So we are going to deal with one or two numericals based on this. Okay, so cells in series and parallel is clear. Now we'll do two basic questions based on this, and one of the question is that two identical cells are given. Two identical cells of EMF 1.5 volt joined in what? Parallel. They are joined in parallel, provide supply to external circuit. Now what is in the external circuit? Consisting of two resistances. It consists two resistances of 17 ohm, each joined in parallel. Now they are also in parallel, each joined in parallel. Okay, and then a very high resistance, voltmeter is voltmeter reads terminal voltage. It reads terminal voltage of cells, and that is to be 1.4 watt volt. That means that is less. There is some internal resistance in cell and we have to calculate that only. Calculate the internal resistance of cell. This is the question. Okay, so how we are going to find out it? Very simple. We will check it out that how we calculate it. We have two identical cells, so I am going to draw it. Say there are two cells identical and they are connected in parallel, and their internal is say, okay, small r, they have identical internal, and this is connected to a external circuit where we have two what? External resistance, and they are what? Each of 17 ohm. So R is given 17 ohm. Small r we have to calculate, and these are the cells, and cells have EMF E1, E2 as 1.5 volt. Okay, got it? And we have to calculate what the resistance here, small r, and the potential difference of the cell is given 1.4 volt when we take a voltmeter across it. So first of all, we will find out the net resistance for this R1 R2 upon R1 plus R2, that is of 17 ohm. So directly I am writing it will be 17 into 17 upon 17 plus 17, and calculate, it comes 8.5 ohm. Okay, and then I am going to calculate what the internal resistance, say R dash is the total internal resistance of cell. Okay, and then can I calculate it? Yes, I know the concept is that E V is equal to E minus IR dash. So can I write here what R dash is equal to, say, if I take E minus V by I. Got it or not? And then you know that I can multiply it by capital R and it also by capital. So it can become E minus V by V into R. Are you getting it or not? Again repeating, R dash is the equivalent, E minus V by I multiply it by external, it becomes a relation. And when it becomes a relation, so E minus V by V into R, can I write it like this? E by V minus 1 into R. So I can put the value. What is E? E is what? 1.5. What is V? 1.4. What is capital R? The equivalent resistance. That is 8.5. To calculate it, I am getting 0.6 ohm. This is the internal resistance which I am getting. And you know, for a cell what it will be, because R dash is actually R1 R2 upon R1 plus R2. So solving it out, you will get R dash and R1 R2 are equal. So we get what? R equal to what? 1.2 ohm. Putting here the values, because 0.6 will be R square upon 2R. Solve it, you get R 1.2 ohm. Got it or not? So this is the answer. Again repeating, very simple. Two cells were given and their combination was in parallel, and then you got the net resistance, you got the EMF, and then what is V equal to what? E minus I R dash E minus V by I. Then you multiply it by R. This R is what? Equivalent of those, and that you put it, you will get a small r dash, and R dash is the combination of two in parallel. So this is one question based on how you calculate it in what? Parallel. There is another question which I am going to discuss right now only in this case, is that there is a circuit given here. Directly I am drawing the circuit, and this is the circuit given. Okay, and there are some external resistors also, and this is of EMF E1, it is of EMF E2, and see there like terminals are connected. This is of 4.5 ohm, this is of 3 ohm, this is of 6 ohm, this is of 4 volt, this is of 8 volt, and its internal is 0.5 ohm, and its internal is 1 ohm. Okay, this is the circuit, given circuit. So given circuit, if you can see the circuit, and what do we have to calculate? We have to calculate current in the circuit. So we will calculate the current in the circuit. I think all of you know. First of all, these are the internal resistance and these are the external. So we should know about the net resistance. So net resistance we can calculate. We know that 3 ohm and 6 ohm are in parallel. Okay, are in parallel. So we will get what? 1 by R dash 1 by 3 plus 1 by 6. I am going to write it directly. R dash will come what? 2 ohm. Then we have 0.5 and then these three. So net resistance will be what? 2 ohm plus 4.5 plus 0.5 plus 1. All are in series. If you calculate it, it becomes what? 2 plus 4.5, 6.5, and then 7, then 8 ohm. So net resistance you are getting here is 8 ohm. And then what is the current? Current will And now tell me what will be the net EMF. In this case, it will be E2 minus E1. Can you tell me why? Because 8 volt is greater than 4 volt and the like terminals are connected. Already we have discussed this. So 8 minus 4 by what? 8. So it will be 4 by 8. The current in the circuit is 1 by 2 ampere or 0.5 ampere. So I think you got it or not. This is very easy. Again, repeating, these two cells, the like terminals are connected. So we will have this E2 minus E1. First of all, net resistance, these two are in parallel, 2 ohm, then all are in series. You will include the internal resistance, 8 ohm. Then what is the current net EMF upon net resistance, 8 minus 4 by 4, and this will be the answer. So this is how we are going to solve the cases of internal resistance. Okay. So now I will discuss the another very important thing. Internal resistance is over, cell series parallel is over. So we will discuss very important thing. Say I am giving you a question right now. If I know this, say 3 ohm, this is 6 ohm, this is say 2 ohm, and this is a battery of say 10 volt, and I ask you find current in circuit. Okay, very simple, find current in circuit. Now we know that we can easily find 3 and 6 are in parallel. It will make what? The net will come from here, it will be 2 ohm. Are you getting it? And then 2 plus 2, so net resistance will be what? 2 plus 2 equal to 4 ohm. Are you getting it? 3 and 6 are in parallel, so it's become what? 2 ohm. And then what is the current? V by what? R. So 10 by what? It is 4. So it becomes 2.5 ampere. So very easy if I ask you find current in circuit. But then what happens if there are more than 2 batteries, more than 3 batteries, more than 4 resistors in? If I say that there are one resistor is like this, another resistance is like this, another resistance is like this, and there is another battery. This is E1, this is E2, this is R1, this is R2, this is R3. Find currents in circuit. Now find currents, not currents in circuit. So you know that for this you need a very, very important law, and that is what? Which law? Kirchhoff's what? Kirchhoff's laws. So we are going to talk about that. We are going to discuss these complex circuit by Kirchhoff's laws. So we'll start with the Kirchhoff law one by one, and such complex circuit will not be easily solved, so we need a law. So what exactly is Kirchhoff's law? So we are going to talk about that. You know that for the complex circuit, Kirchhoff gave two concepts and he extended for the complicated circuits. When we talk about the complicated circuits, not the simple one. So we'll talk about how we, so there are two laws given, and one is, the first is Junction Rule. That is current law. Okay, and in that short term we say KCL, Kirchhoff's current law. So this is the first rule. Now what this first rule says, according to Junction law, what it is the say, that in an electrical circuit, what is the statement? See, in an electrical circuit, the algebraic sum of currents at any junction, are you getting it? Any junction is 0. This is the first law. Or we can say sum of input current is equal to sum of output current. We can say like this also. The current entering in the circuit will be equal to the current leaving in the circuit. Entering in the circuit will be equal to leaving from the circuit. We can say like this. So total summation current is what? 0. And this is Junction Rule. Got it? Electrical circuit, the algebraical sum of current at any junction is 0. I am going to represent it. And how I am going to represent it? Say there are 4 resistors I have given, and I am just explaining it. and say this is current I1 and this is current I2, this is I3, this is I4. Now if you see at this junction, what will happen? I1 plus I2 is equal to what? I3 plus I4. These are the input current, these are the output going on. Or we can say I1 plus I2 minus I3 minus I4 is what? 0. Or summation of I is what? 0 at a junction. We can write like this also. At junction. So this is the junction where the net current is 0. And remember that it is based on what? Very important thing. And it is based on law of conservation of charge. Okay, law of conservation of charge. You remember I is dq by dt. And when I say q is what? Constant. Certainly I is there what? 0. So this is junction rule, very simple rule where we can apply it across the junction. We can find out the sum of the entering current is equal to the sum of the leaving current. This is the simple law, first law, KCL. This is also known as first law. But the second law is more important because it is going to help you out and solving the complex circuit, and that is Kirchhoff's second law. And this is also known as loop rule. It was junction rule, it is loop rule. Or this is also known as voltage law. And in the short form we can write Kirchhoff's voltage law, KVL. Now what is this? This statement is very simple, that in a closed loop, you have to always take a closed path. In a closed loop of a network, okay, in a closed loop of a network, the algebraic, okay, sum of changes in potential must be 0. That is total potential difference must be what? 0. Sum of the potential difference. We can directly write. That means summation delta V is what? 0. That is, and it is based on, see, that was based on law of conservation of charge. It is based on law of conservation of energy. There can be one mark concept question, law of conservation of energy, that was based on charge. It is based on law of conservation of energy. So in a closed network we are going to see that total potential sum must be 0. And how I am going to apply it, see it. It's a very important thing now when I am talking about a circuit. Say there is a resistance R1 and there is a resistance say R2. And this battery has EMF E. And the current is flowing like this. If I ask you what is the current, so you will say E upon net resistance R1 plus R2. But now I am saying about apply Kirchhoff's voltage law. First of all, you have to define the path A, B, C, D. Path define. This is the path. Okay, it can be in any way. Now how you are going to apply? We are applying KVL in closed path, and always it is applied in a closed loop. So it is also known as loop rule. And path is defined as A, B, C, D, A. We are going in this way. We can go in a clockwise or anti-clockwise way. So we are starting from here and we have to end at A. Remember, not A, B, C, D, A, B, C, D, A. Okay, we'll check the potential. So what is the current going on in it is I. So what is the potential difference? IR1, what is here? Plus IR2. Are you getting it or not? The potential of difference. And then you are coming, this is also a cell. It has a minus E will be equal to what? 0. This is the total potential. Why minus E? Do you know you are coming from positive to negative. When you end at a negative, it will be minus E. But when you end at positive, it will be plus E. So this is you are going to solve. This is the equation. And if I further solve it, it gives the same answer. Do you know? It gives the same answer. The answer you have taken earlier. And if you say I am going to follow the other path, no, I am going to follow DCB AD. Now see here, I am going to follow the reverse one. Can anyone tell me what will be the law? Yes. Now you are opposite to the current. So the current will be minus IR2 minus IR1. And now you are coming to the positive end, plus E. Plus E will be 0. And ultimately you see it becomes, what do you know? IR1 plus R2 equal to E. And the answer is the same. E upon. So answer is not going to change. Answer will be same. But the way you have applied, one you are going in a what? Anti-clockwise way. That is, this is anti-clockwise. And one is you are going in a clockwise way. And remember one thing, when you go from positive to negative, you have to take minus E. When you are along the current, that is along the current, then it is positive. You are going in. But when you are opposite to the current, then you have to take negative. Are you getting it or not? So this is how we are going to apply Kirchhoff's what? The voltage rule. So this is how we are with Kirchhoff's second law. In a closed path, the total sum of the current, the total sum of the voltage will be 0. Law of conservation of energy. We have applied this here, and one is we are going in this way. So this is the equation, and another we are going to in this way. This will be the equation. So in next class we are going to discuss the numerical based on Kirchhoff's law. Just go through the concepts of the Kirchhoff's voltage rule. Along the path, current will be positive, but when you go to minus E, you are going minus E, you will take minus E. But when you go opposite, current path will be taken negative, but it is going to plus E. So this is way we are going to solve it. Okay, and solve the assignment. Thank you, and watch all videos.